Okay, this is actually, I think, my favorite lecture of the entire thing. It's on test-driven development. And I've already told you about how important I think unit testing is, how it made such a huge difference in the way that I think about testing. And so this one is going to talk about an awesome way to make use of unit testing. And so this lecture is about what's called test-driven development. So now, first of all, before unit tests came on, just to be brief, we used to do manual testing. The QA department would manually test, send the bugs to me because I was the one that had all the bugs. I'd fix them, send it back. They'd verify that I fixed it, see if I introduced any new ones, send it back, and so on, and back and forth and back and forth. And then in 1997, Kent Beck introduced something that he called JUnit. Well, he introduced unit testing by introducing the system that he called JUnit, which stood for Java Unit. It was originally done for the Java programming language, and it was unit testing. So it was a unit testing framework for showing how to do unit tests, similar to what Jess does, where it shows you, runs all the tests, shows you the results, and so on. And this was for Java. So it was JUnit, and it really just hit with a bang and had a huge impact. Took me several years to figure out what was going on with it and how important it was, but it started gaining a lot of adoption. So again, I love this test. Unit tests embody the aphorism that all code is guilty until proven innocent, unlike our justice system. So your code is guilty until you prove that it's actually working, and you should treat all your code like that. All code has a bug in it until you prove that it does not. And sometimes you think you've proved it and you still haven't. Anyway, so we started using unit testing quite a bit. And then people started saying, well, what's the best way to use unit testing? Typically, how it was used was you would sit down, write your entire application, and then start writing a bunch of unit tests to test it. And that was a fool's errand. I can't tell you how many times I've had people tell me, I don't have any unit tests because I didn't have any time. Once I was finished with the code, I didn't have time to write the unit tests. And that is just broken. So you lose all the advantages of unit tests. So then okay, so you should write your unit tests much sooner than when you're all finished, but where do you write them in the process? And Kent tried to just turn that whole paradigm on its head. And he said, no, you shouldn't write the unit tests last. You should write them first. And so that is what's called test-driven development. So you write your unit test. It fails because the code's not written. You write the code until it makes the unit test pass. And then you write another unit test that fails because because the code's not written. Then you write the code that fixes the unit test, and so on and so on. And this is the process that we're going to use. So this test-driven development. It's a wonderful process. Highly recommend it. I think everybody that tries it says this is great, and then they adapt it to their own work style, like I've done. I don't always write the tests first. I sometimes do, but I'll write them very, very early on, and I'll just kind of have my own little process for how I do them. But I think it's important that you understand the process as it's intended. Try it, use it in how you're going. Unfortunately, we don't have the environment set up so you can actually run unit tests right now. So this will come later in your progression. But when you do get to the point where you're doing unit tests, once you're comfortable with unit tests, try test-driven development, try following this process precisely. And then once you've done that, you understand how it works for you and where you could improve it, and then you kind of adapt it to your own style. Now, that's true of pretty much everything we teach you. You should do it exactly as we tell you, and then as you get more comfortable with it, you're going to start finding the things that what we said is a little too rigid, or you find a better way to do things. And that's fine. That's expected, and it's how you should go. But you should learn the precise way first, and then adapt it once you really understand how it works. All right, so let me go through what the test-driven development process is. There's 3 steps, 3 phases in the test-driven development process. and you cycle through them, repeat over and over and over and over and over again. They're called the red phase, the green phase, and the refactor phase. Now in JUnit and in Jest, if there's an error, it displays it in red. If the test passes, it shows it in green. And so these are named after that. Sorry for people who are colorblind. I don't know how they tell. They have to actually read it. But I'll have to ask Sean someday how he does this. But anyway, the red, green, and refactor phases. So in the red phase, you write a test. And you make sure that the test fails, and it fails because the feature you're trying to work on. So, sorry, back up. First of all, you say, this is the feature I'm going to work on. Then you write a test that fails because that feature has not been implemented. That is the red phase. Once you get the test written and failing properly, then you exit the red phase and you go into the green phase. In the green phase, you write your code that fixes that test, and then the test turns green. So okay, good, I'm done with the green phase. Then you go into the refactor phase, and in the refactor phase you clean up the code, because often when you're doing this part and you're just trying to get it green, you write ugly code, and so you want to go back and clean it up. Once you have it working, then you're going to clean it up and refactor it, make it better. So let me go into these a little bit more detail. So in the red phase, you write the test, and the test must fail. If the test doesn't fail, you haven't written the test properly. It must fail. It's amazingly easy to write unit tests that pass, even though they don't test what it is you're trying to test. So it must fail because the feature that you're trying to test is not implemented. And you're only allowed to write just enough of the test to get it to fail because of the missing feature. You're not allowed to say, oh, I have to do features 3, 4, and 5 sometime too, so let me write those unit tests now. Not allowed. You're only allowed to test exactly the thing that you're trying to implement right now, and only a small enough test that it just fails. Okay, and that's it. That's all you're allowed to write. Okay. And often when you write that test, you'll figure out, oh, this is how I want to do my API for this thing. And so you'll learn a lot of stuff during the writing of the test. But anyway, that's what you do. Now, this red phase really sets off normal unit testing processes from test-driven development, because it's in the red phase that you do that first, and that's what makes it different. Okay. All right. So in the green phase, you now write your production code, but there is a rule here. You may only write enough code to make the test pass. You do not write anything that is not necessary to make that test pass. So hopefully it's just a tiny amount of code that you write, just enough to make the test pass. Maybe it's ugly. Maybe it's code that is, you think, oh, gee, really? I know that I really should have a loop here instead of just assigning it a fixed variable. No, not allowed. You're just allowed to write just the tiniest amount of code you can think of that will make the test pass. The reason for that is because you don't want to go in and start writing all of this elaborate new code without tests that prove that you're doing it correctly. So you write the test just enough to get it to work, and then you say, okay, now I've got it working. I'm out of the green phase. I'm going to go into the refactor phase. Now, in the refactor phase, this is where you are now allowed to look at the code that you wrote before, and you said, I really just did an assignment up there. It was ugly. I probably should have had a loop or whatever. Now here's where you're allowed to do it. You do it here because you have all these tests that are showing that that you're not making mistakes. Again, as it's so easy to write code, and especially when you're trying to generalize the code and actually break something. And if you don't have tests, you're not going to know it. So you can't refactor until you're all green. Once it's green, then you can do all your iterations and your refactoring, and you can feel pretty confident that the refactorings that you didn't actually break anything. They kept everything working correctly. So that's the refactor phase. So I break this down into a small set of 4 rules that that are easy to remember. And here they are. You are not allowed to write any more of a unit test than is sufficient to fail. Okay. So you may only write enough of a test to fail. That's it. Don't get more elaborate than that. Similarly, you're not allowed to write any production code unless it is to make the failing test pass. You cannot write code anywhere unless the purpose of that is to make your test pass. And then, so don't get the temptation to go off and work on something that's unrelated to the unit test. So if its purpose is not to make the test pass, you don't write it. And then you only write as much as necessary, the smallest amount necessary to make the test pass. Okay. And then you may only clean up your code in the refactoring phase. Those are the 4 rules. All right. So I kind of went through those kind of quick because I'm now going to demonstrate it. We're going to do some test-driven development together. And so here we go. When Kent Beck first demonstrated unit testing at a conference in 2001, he used this example. And so we're going to do the same example that he did when he did it. The example is convert a decimal number to Roman numerals. Okay. All right, here we go. In case you don't remember your Roman numerals, I is 1, B is 5, X is 10, L is 6, so on. Okay, these are the Roman numerals. And so to convert 11 to a Roman numeral, it would be XI. Yep, okay, so on. All right, so we're going to write that code. All right. And remember that when you get to 4 is not I, it's IV. Okay.
And then, for example, if we wanted 2000, I forgot how is it?
2000 is MM.
MM.
Yeah, yep, that one's fine.
These are the Arabic numbers 1, 5, 10, 15.
Okay, here we go. So I got it set up here. I'm using in this example something called the Jest plugin. And I love it. It's very, very nice. Unfortunately, I couldn't get it set up to work in our repo because our repo is too big. And so I have to show you here with this. But what it does is you write your unit test. And as you write your unit test, whenever you save your files, the plugin will run all the unit tests for you. And it will actually show you which one succeeded and which one failed. So this one, it shows with the red underline that this test failed.
Oh, it shows
Okay.
you directly here in the code.
Yep, right in the code. So it says expect true to be false. So if I hover over it, it will say, expected false, but it got true. So just tell me what went wrong. So expected is here. I expected it to be false, but what I got was true. Okay, so that's how you read that. And so this is very, very nice. And I'm going to use this to set up. Okay, so I have it going. I first of all created the function called toRoman. And so I'm going to call this, I pass it a decimal number and it returns me a string, which will be the Roman numerals. Okay. All right. So right now it's just got a stub implementation. It returns an empty string. So let's get going. What's the first thing we might want to test? Maybe 1. What does 1 go to? I. Okay, so I'm gonna expect toRoman of 1 to be I. All right, save. The test runs and it fails. Okay, so you see it fails. It expected I, but I got an empty string. Okay. All right, so let's go fix it. What's the easiest way to fix this?
Creating a statement.
The simplest way to fix this, I can fix it by typing one character. What is it?
I into the return string.
Return I. You say, but Robert, that's stupid. That doesn't convert it to Roman numerals. And I'll say, yes, but I'm in the green phase, and the green phase says I am not allowed to refactor my code. I'm not allowed to write any code other than the simplest necessary to make the test pass. And this is the simplest necessary to make the test pass. Okay, so that's the rule. When I'm in the red phase, we got out of the red phase because I got a test that fails. And now I go into the green phase, and the only code I'm allowed to write in the green phase, this is my VS Code is running very slowly. Let me try shutting a bunch of things, bunch of windows, see if that helps. Okay, so and when I'm in the green phase, I'm only allowed to write the absolute simplest code that will make the test pass. So I believe that will make this test pass. So let me save. See if it did. Save. Switch over to here. I think I'm going to actually pull this over to here. And you see it's now green. So it passes. Okay, good. Okay, all right, cool. Now, after the green phase, we do what?
Refactoring.
Refactor. Do you see anything I can do over on in this code to make it simpler?
Not simpler, but you can refactor it to make it more dynamic for all of them.
Not allowed. Only allowed to make simplifications to my code. I'm not allowed to write code that will I'm not allowed to write code for tests that don't exist. So I'm not allowed to write how it's supposed to work for 2 or 3 or 4 or 5. Not allowed. I'm only allowed to do the simplest thing I possibly can to make this test pass. Okay, and now I refactor. I'm only allowed to refactor this code to make it simpler. All right, because otherwise I'd be writing code for a test that doesn't exist. So I've been through the red phase, the green phase, and now in the refactor phase, I don't need to do anything. So now I cycle, do it again. So let's write another test. So to do this other test, I'm going to duplicate here. And what should I test next?
V is 5 is V.
Is that the best next test? Don't you think 2 would be a good test?
It's like right?
Yeah, see if 2 gives me II. Okay, seems pretty reasonable, doesn't it? So let's check to see if 2 gives me II.
Kind of.
Okay, run. All right, it failed. Why did it fail?
Still have them.
I expected II, but I got I. So good. That's what I want. I want a failing test that fails because I haven't yet implemented 2. So therefore, I am done with the red phase, and now I'm going into the green phase. How can I fix my code? The simplest way possible.
Add another I to the return statement.
Okay, if I add another I to the return statement, let's see what happens.
The first test will fail.
The first test failed, so that was not a good way to do it. So what am I going to do instead? So I put it back, if else. Okay, let me just do it. Sure, I'll do an if else.
Oh, I see.
If decimal equals 1, then return I. Otherwise, what am I going to return?
So
I
have a question, Robert.
Uh-huh.
So basically, we are slowly building up the functionality of the function.
Exactly.
Test small steps.
Yeah, the tests tell me what to test next and what code to write next, and then I gradually get it up until I have it fully working. Okay, so here we go. I and oh goody, the test passed. So now I have successfully exited the green phase. So now what's after the green phase? Refactor. Do you see any refactoring? Any way I can simplify this code? I don't see anything I can do to simplify it. So let's cycle around. We go back to the red phase. In the red phase, I have to write a test that fails. What's another test that you think is going to fail?
3.
3. 3 should be come on. I. Come on. My VS Code's still kind of slow. Sorry. All right. Now, if I save, then it'll run the test and hopefully it'll turn red. And the other ones stay green. Yes, good. So this is now red, and it's red because expected I, and only got I. Okay. All right. So I have successfully completed the red phase. Now I'm going to go into the green phase. How do I fix this code?
We need an else statement. Or we can,
Okay, yeah, I can just do it simple like this. I'm gonna say if I equal decimal equals 2, I'm gonna return I. And then if it's not, I'm gonna return I. Okay, you can think of other ways to write this, but that's a simple fix. Save. The test is now green. Oh, yay, I finished the green phase. What comes after the green phase?
refactor.
The refactor phase. Can you think of ways to simplify this code?
No.
I'm starting to look at it now and think this is pretty ugly.
Oh, it's looking ugly.
Yeah, I checked to see if it's 2, then 1. I mean, there's
Okay.
got to be something simpler here. Maybe it's time to do a loop. Okay, so I'm in the refactor phase, so I can do this kind of refactoring. I can do this if I do a loop. For let I equal 0, I less than decimal, I plus plus. Let me get myself a Roman numbers variable.
Jeez.
Let Roman equal an empty string. And then I'm going to say Roman plus equals I, and I'm going to get rid of these things, and I'll return Roman. Look okay? So I've done a refactoring. Before I do anything else, I need to save it, make sure my test passed, make sure my refactoring didn't break anything. So I save, and test still passed. Okay, so my refactoring didn't break anything, and I think it made the code simpler and more usable. Okay, so I think anything else I could do in my refactoring here kind of looks okay to me. So let's go on. We're done with the refactoring phase. We cycle back around to the red phase, which means we need another test. Duplicate, and I'm going to test. What's a good thing to test now? What do you think is going to break?
The I.
I think the 4 is going to break, actually.
The I is going to break because it's gonna need a V.
Yep. So if I put 4, I expect to be IV. Let's see if that works. Okay, it failed. And I expected IV, but I got I. So,
Oh.
all right, so good. I found a test that fails, and I need to go fix it. All right, so now I'm going to go fix it. What's the easiest way to fix this code?
Now this one's gonna keep adding up to the end, so it's gonna be a
Okay, I can write one line of code to fix it.
reset, like try to
If
reset.
decimal equals
4.
4, return IV. Okay, does that fix the test? Yes, it does. So it's the simplest code I can think of that fixes the test. That's all I'm allowed to do in the green phase. Save. Good. Perfect. You're all sitting there thinking, but that's stupid. That's not solving the problem for me. No, it's not.
Simple.
This is test-driven development. We're just going a small step at a time, and we're testing in every single phase. So now we've finished the green phase. What's after green? Refactor. Can you think of anything I can do to clean this up and make it nicer?
Right now. Maybe later, right?
Gonna put the statement inside the for loop.
If I put it inside the for loop, won't it break? Let's try it. You mean this?
After the
Or like resetting.
logically, because logically we don't want it to be at the top if it's a bigger number.
When I did that, my test still passed, so it didn't break, but to me it looks kind of startling. So I'm gonna put it back like that. Okay. All right. I could do it down at the bottom. There are, different ways you could do it. Okay. I could say, anyway. All right. Let's do another test. Let's move on. So we're going to go back and we're going to do the red phase. So the next thing,
Create
which do you think is going to fail? I think 5 is going to fail. Whoops. 5 should be just V. And it fails. It says I expected V and I got and so how do I fix it? I've now finished the red phase. Let's go green phase. What do I do? How do I fix it? Easiest way. If the decimal is 5, return V, save, and good. It fixed it without breaking anything. So that's the green phase. Now I can go to the refactor phase. Now I'm starting to think, ooh, this is getting ugly. What do I do? What do I do? I'm not quite sure yet. I mean, I have some ideas. Like maybe I should check to see if it's bigger than 4 and then put a V in and so on, but it's not quite, it's hard for me to figure out right now. So I think I'm going to skip the refactor phase. You don't have to do the refactor phase every time. I'm going to skip it and go on. What's the next test? What test do you think will fail?
The 6.
6 is going to fail because it should be VI, and I'm guessing it's not going to give me VI. What do you think it's going to give you? Give us.
6 eyes.
6 eyes. Wow. I've been called 4 eyes before, but not 6 eyes. Okay, so sure enough, it fails. So now the easiest way to fix this is, of course, to add the extra if statement. Save. It's now green. Okay, now I definitely need to figure out how to clean up this code. This is really bad. I don't like this at all. So I need to figure out what to do here. It seems like, anybody have any bright ideas?
the other way we can reset it. Do reset, and when it reaches certain number, reset to 0, then start hiding out.
Yeah, we could try something along that when it reaches a certain number. Okay, let me instead of forcing you to just sit there and work through it, in the interest of time, I'm going to suggest I'm going to get started. You be my code completion AI, and I'll start writing. You see what you want me to write. I'm going to say let's declare something called the remainder, which is everything that we haven't turned into a Roman numeral yet. Okay. And so now I'm going to go and I'm going to change all these things that say decimal to say remainder. So select, Control D, 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 paste. So they all say remainder. Did that break anything? Good. Everything still works. You notice even something simple like that. I'm going to run my tests again because it's even a simple thing like that. You can accidentally break something. So I save, look at the test, make sure they're still running. Okay, so now having told you about remainder, what if I do something like, any thoughts yet? If remainder is greater than 5, then what do I want to do? Let me put Roman up at the top so I can work with it. What'd you say?
Later until it reaches 10 and add an I.
Well, I haven't got a V in there yet. So first thing I have to do is add a V. So let me add a V. And then let me lower my remainder by 5. Okay. So I don't need this anymore. I don't need that anymore. Let's see if this works. Did I break something? Yes, I broke 5. Expected V. Okay, so if it's greater than or equal to 5. Okay, good. So again, you see small steps. Check it every single one to make sure you got your logic right. That look okay? Okay. Well, we don't even have to ask ourselves that question. Is this going to work on the next one? We don't know, we don't care. Okay, we don't know, we don't care. So all we do is say, is this the nicest way I can write this code, or can you think of a way to write it nicer? So I kind of like it. Of course, I wrote it, so that's why I kind of like it. But anyway, let's go on. Let's do 7. Do you think it's going to work for 7? I think it's going to.
Why did you call it remainder?
Because it's what's left. I start with the decimal I was given, and then I have what's left after I process the 5. So I say I process the 5 by putting a V in, and then what's left is that. Okay. So that's why I called it remainder. But
It's like similar to resetting.
yeah, similar to resetting. Okay, 7 worked. I'm pretty sure 8 will work. How about 9? So let's just skip to 9 because I'm pretty sure 9 is not going to work because 9 should be IX, and there's no X in my code anywhere, so I'm sure that 9 is not going to work. Okay, so here we go. And sure enough, I expected IX and I got IV. That's weird. Okay. All right. So what's the easiest way to fix this test?
Just.
Yeah, we've done this a lot.
Yeah.
If decimal equals 9,
Because there's not going to be a lot of,
return IX.
but there's so many numbers, this can.
Why did you get IB though?
Because tell me, what line is the bug on? I don't want to fix it right now because it's not allowed. I saw it and I thought, okay, let me fix that. I thought, no, wait a minute. I need to have a test for that.
Is it because of
Where-
line 9?
It's line 9. Yep. If remainder is 4, it returns IV. I should have said instead Roman plus equals IV right there. Okay, and so on. All right. So I've got my tests all passing. I'll scroll just to make sure they all pass. Now I can do some refactoring. So I'm going to fix that bug right now in the refactoring phase, make sure I don't break anything. So I want to fix this bug that we noticed, and it should say Roman plus equals IV, and then save. Whoa, whoops, that broke this one. I got IV, I. Whoa, why'd that happen? How do I fix that? See, I'm allowed to fix it now because I have my test working, and my test will tell me when I screw up. So what's the problem here? Nope. I have to reduce my remainder by 4 because I processed the 4, so I have to take it out.
Oh.
Okay, so you see that? That makes sense. All right, good. Now, what about the 9? Again, I can see that I'm going to have something similar to this when I'm processing my 9, but I don't know exactly how it's going to work yet. So let me add another test. So I'm going to skip refactoring. Well, I did some refactoring already, and go around to the weird. Okay, duplicated it twice. I think 10 is going to fail. So let's fix 10. It's a little annoying in jest that I have to write this test basically twice, but maybe an AI someday will make it so I don't have to do that. All right, so I wanted X, but I got V with a whole bunch of I's. So IV, let's see. So let's see, again, the simplest way to fix it. I'm in the green phase. I need to be careful. I almost started writing complicated code, but I realized just in time that I'm not allowed to do that. So that's the easiest way to fix it. Here we've got 10. Okay, now let me, I'm done with green. So let me refactor. Now it's kind of clear that I'm going to have something similar to this right here with the I greater than or equal to 5, something like that. So let me just duplicate that code there and change this to a 10. It's greater than or equal to 10. I'm going to put in an X and I'm going to subtract 10 out. Save, see if I broke anything. Everything's green. So that's looking a lot nicer. And oops, I forgot to get rid of this line up here. And I probably don't want this here, this check for 9 up here. I probably want it down below here to make it more similar to how I did the 5. And I want to do this same thing, right? So it's going to say Roman plus equals IX and remainder minus equals 9. And just make sure I didn't break anything. I'm not totally convinced that's going to work when I get up to higher numbers, but I think so. But I'm not exactly certain. So we'll try it out. So now that's all the refactoring I want to do. Let's go write another test. 11, I'm pretty sure 11 will work, but let's just check it to make sure.
It's gonna be going forever.
Yeah, all the way up to 1,000.
They'll make like a
Really?
one function that does the whole thing.
No, one test, you mean?
No, I mean like a one.
This is the.
Yeah, one function. Yeah, eventually you can, if you go through this process, you'll get it to you have a pretty clean function that goes all the way up to
Instead
1,000.
of like checking.
Yep,
Each
Yep,
one.
yep. You have to check each one. Okay, 11 worked. I'm pretty sure then 12 will work. 14 is going to be an interesting one. Anybody think of some other interesting ones we should check? 14 should be XIV.
That's why I'm writing this.
Okay, yep. If you, yes, aren't Arabic decimal numbers
Yeah.
awesome? Okay, so 14 worked. How about 15? Should be XV.
It's working without any changes.
Yeah, isn't that nice?
Oh,
Because we've refactored our code, it's working. So where's one that we think is going to fail? I think I should try 16 just to make sure I get that I on the end of it. What's one that somebody thinks might fail? Pretty sure this is going to work. Pardon?
1,000.
Well, we got to work our way up there. You can't just jump to 1,000. Okay. All right. What should I do now?
This is a great way to learn through these unit tests.
I'm going to do 19. I'm a little worried about 19. It might work, but I'm not 100% convinced. Is XIX going to be 19 going to be XIX? No. Okay, it didn't work. So I got XVIV. That's interesting. So this check right here that I did didn't quite work. Interesting. Let's see. Why did it not work? Before I do anything, yeah, so let me figure out why it didn't work, then maybe I can fix it. I know I can always add an if statement at the top. But let's see. I come in with 19. 19 is greater than 10, so I get the X. That's good. And I subtract the 10 and I get 9. If that's you see the bug?
Oh, it's not remainder, but decimal.
Yep. Okay. Save. Then it works. Cool. What do you got? How far on this do you want to go? Okay, I'm pretty sure the 20 is going to fail. So at some point you have to start saying, okay, I mean, you can't do tests from 1 to 1,000. You'll go crazy. So you kind of have to start sampling, here and there and what they are. But 20, I'm pretty sure is going to fail. Yeah. What's it going to give me?
XIXI.
Close. XV. Okay, so 20 came in, it was greater than 10, so we subtracted out. And then we went here, and then we went here, and then skipped this one, went here and got the V, skipped this one, and then we had 5 eyes left over. 4, I get 5, 4. We had
Oh, so
5 eyes left over.
so this is why using F, so keep.
Yeah.
keep-
Yep, and it just kind of cascades down.
Wow. that's
Okay,
nice.
so here's probably what I want to do. Change that to a while. What if I do that? Now, as long as the remainder is less than 10, greater than 10, I'm going to subtract 10 and put an X in. So that'll give me XX for 20, XXX for 30, and so on. So that sound clever?
Yeah.
Let's see if that works. Ah, and did it break anything? Got to always check if it broke anything. No. But let's see if it works for 21. 21. 21. What should 21 be? XXI. I think it's going to work, but it's always good to test. Save. It worked. I'm thinking that it'll work for 24 and 25, but I should just put them in and check. 24 should be XXIV. XXIV. Save. I think that's going to work. I think 20 is going to work. It's possible that, or 25, I think the 29 might even work. 25 should be XXV. This did, oh, whoops. Wait, I mistyped. Okay, 25 should be XXV, and that worked. 29 might work. That's the next one that would be questionable to me. It should be IX, and then 29 should be XX, save. That worked. Okay, what's going to fail? Anybody can guess what's going to fail? So 30 should work. All the 30 should work. All the 40 should work until I get to
So 50 then.
what's 40, 49.
42.
49 you do as, I'm actually not certain how you do 49.
Isn't
Actually, it's not going
isn't
to
it
work for
the
40.
50?
Not going to work for 40. What's 40 supposed to be?
Isn't it a different symbol?
L is 50. Who remembers what 40 is supposed to be?
C?
L is 50. So what's 40 supposed to be?
Excel.
XL. Excellent. Someone remembers their Roman numerals. So this should be XL. And of course, we know it won't work because there's no L in our code anywhere. So I got something that's reasonable, at least, XXXX. But that's not the way that you're supposed to do it. So I need to now, I'll do this one, then we'll stop. So I'm going to say, to avoid future bugs, I'm going to put my check right here. If remainder equals 40, return XL.
But why is it XL? Is it because it's minus
It's
10 from 50?
yes, that's why. Yep. Okay. So now I can't really think of a good way to fix that one. But if I do 41, it's going to fail. So let me do that.
Robert loves unit testing.
41 is supposed to be XLI, and 41 XLI. Save. That one failed. So let me quickly fix it. 41 is XLI. So save. Good. They all work. Then let me see. So I need to do I need to do the same thing here. If it's 40, then I need to do the Roman plus equals XL, remainder minus equals 40. I think that's what I want. Get rid of this guy. Now I have tests in place. I can check. Nope, that didn't work for 41. Why is that? Oh, yuck. Got hit, stuck on this one. This one's nasty. We have to think about this one.
It's too bad it's up there, because if it was down below, it'd run last. It has to be.
Yeah,
But this one and was the same question was in lead code.
converting to a Roman numeral.
Yeah.
Yeah.
Someone.
Well, it's a very famous problem, so probably isn't leak code. I actually don't have a good solution to this. What am I supposed to do?
But why did it get stuck on that one? Shouldn't the if statement run first and then we'll be left with just one?
That's correct. I put in XL and then I hit the remainder is greater than 10. So I put in a bunch of X's. So I could do if this is ugly, but it will fix the test. If remainder equal is less than 10, read Roman plus equals, well, see, I have to have all of this logic in there because 49 should be XLIX. So the problem is I hit this loop right here because I had 41, so I had one left. Okay, if it's equal to 1, then Roman plus equals I, and remainder minus equals 1. That should at least fix the, oh, no, now I broke 40. Oh, sorry, I didn't want less than 1, I wanted equals 1. Oh, no, I thought that was going to work. Oh, sorry, I said if. I should have said greater than or equal to 40. There, finally they worked. Okay. And this is ugly. So now when I go into the refactoring, I need to figure out how to make that less ugly because it's not going to work for 42 and etc. So anyway, at this point, it's 10 o'clock. And so I'm going to leave the rest of it as an exercise up to the student.
This
Okay.
has been recorded, right?
Yes, it is being recorded. I did get one prior class to get to 50 something. So let me see what they did. This is the solution they had. Nope, that's not, this is not the best solution to date. Where's my best solution to date? Drat, I've lost it. Because they got one that worked all the way up to 100. And I can't remember how we fixed this problem.
It's gonna be like
XL,
longer than this
the
one.
40s are tough. So I should say, anyway, sorry, this is no longer a TDT problem, and I have to confess, I'm stumped at this point. I don't know how to make it so it works for all of these without just taking this code and duplicating it over and over again, which I don't want to do. Maybe if I put while remainder is greater than equal to I don't know. Okay, so if it's in the 40s, then I have to do something. I want to skip this. This is what I want to do. So I have my test working so I can play around with, so I'm sorry. If remainder is greater than equal to 10 and remainder is less than 40, 50. That worked. Now let me just spot check. Spot check. 45. and 49. That's interesting. Convert 49 to Roman numerals. XLIX. Yeah, okay, I was right. Okay. Okay, my spell checker doesn't know.
What about million? What would be million?
This one failed. Why did this one fail? It failed because I got XLI, but why? Remainder for it was 9, so I skipped this. It should have gone in here. 49. Oh, because I typed it wrong. Okay, that was a case of my test being wrong rather than my code. Okay. All right, and now we can go 50 and on. Now I feel better turning this over as an exercise to the student. Okay. All right. So anyway, you kind of get the idea of how the test-driven development works.
Could you just I have a question about the, you're gonna go over it, right?
Sure.
Okay.
I wasn't going to. I was going to wrap up and end. So quick question.
Yeah, the other way. So this, what is happening, for example, if we are passing 49?
I pass at 49. So 49 is greater than 40. So I put in an XL and I subtract 40. So now remainder is equal to 9. It's now why did I have to put this? That's an interesting question. So now remainder is equal to 9. So now I come here and it's not greater than 10. So it's going to go here and I'm going to get an IX on it. So that suggests that this should have worked without this check here, but it didn't. And it did. Okay. So there we go. That works.
Stand for 41 as well. Why did it go into that loop?
For 41. Okay, so if decimal is 41, that's 41, it's greater than 41, I put on XL. And then if it's greater, it's 1. So now it's gonna skip this, it's gonna skip this, it's gonna skip this, and it's gonna skip this, and it's gonna go through that.
Oh, I think initially you had the triple equal, the strictly equal instead of greater than or equal to 40. I think that is why it failed.
Ah, that was what the bug was. Okay, good. Thank you. I was getting kind of weird. It was looking kind of weird because I thought, why did I have to do that? Okay, so good. Now it works, and now it looks reasonably clean. Now you know, of course, you put in a 50, and you can kind of get to get your L for the 50, and you can now figure out how you would go beyond this, right? Thank you, Rakaya. Anyway, that's test-driven development, and you see how you can just do it a small step at a time. If I had sat down and said, I want to write a function that converts decimals to Romans, I don't think I'd ever come up with anything that was like this at all. I'd have been scratching my head for a long time. And as you go and you start refactoring, when you finally get up into the bigger numbers, you have a whole bunch of these down in here and you go, yeah, there's got to be a simpler way, and maybe you'll convert it into some table that your lookup table that helps you out.
Yeah, that was like.
But you can do that kind of work because you've stepped up there and you now understand the process and the mechanism, what the logic is and how it's supposed to work. So doing this test in this fashion taught me a lot about how this problem should be solved. So that's what you do. And at every step of the way, you're running your tests. You keep all of those old tests to make sure that you don't break old tests. So you keep them all there, keep them running, keep checking all the tests, make sure everything's still working. And just small steps every step of the way. Fix the test before you fix the code. Okay, so make the test pass before you fix the code. It's very, very important because as you're fixing the code, you don't want to introduce new bugs. You want to make sure you have a complete set of tests to make sure you're not breaking your code. Okay, yeah.
I was just wondering, so all big applications do have test units that come along with, usually if somebody orders, oh, I would like you to create this application for me now. And then when you are the creator of this application, you usually run your own tests to make sure that everything is working properly, or how would this work in the real world?
In the real world, you'll be given a task to do, and you'll sit down and probably you'll be saying, okay, write me a function that converts decimal numbers to Roman. And that's it. And you'll have to sit down and figure out how to do that. I suggest you do it like we did here. You start with unit tests, and then you slowly build up the logic to make sure that you're getting the logic correct as you go along. Okay. If I had written really fancy code with lots of looping and checking and everything in it, and then I started saying, okay, is it working? Is it working? I'd have to come up with all these tests and write them all, and I'd have 10 of them failing, and I'd be completely lost as to where it was my bugs were and what was happening and so on. So, so this is, you know, you will write these tests. Okay. If you go into a company and you might find that they have very few tests. There are unfortunately still software developers in the world who are not very clean about their testing, and they don't write a lot of unit tests. Those companies generally fail. After I left Google, one of the companies I consulted for was working on a project that had been in development for 4 years, and they still couldn't get it out the door because of all the bugs and feature creep and other issues. And that wasn't just bugs, but they had all these bugs. And I went in and I started looking at the code. I said, you've been working on this for 4 years. Let me see all your unit tests. And you guess how many unit tests they had? 0. And I said, you're never going to get this thing shipped without unit tests. And so the developers screamed, but I forced them to stop everything they were doing and spend a week just writing unit tests. And that's all they did, was write unit tests for a week. And I fixed up a bunch of other stuff that they were doing, and we shipped it in 3 months. Okay. So this is the kind of thing that happens. You'll get into companies that don't really understand the value of testing, especially smaller companies. They won't have unit tests all over. They won't have them written, and they'll be in trouble. And most likely they'll be in trouble, and they won't know it. But the time will come when that company, by the way, is out of business now. They just, you know, they kicked me out. Well, I left, and kind of mutual agreement. I was costing them too much money, and they went back to their old development practices and couldn't get their next version of their software to ship, and they went out of business.
Wow.
Okay. So, you know, you've got to have unit testing, and you just can't succeed without it. And if you're getting the most effective way to use unit testing is through a test-driven development process or something like it. So guarantee that you have lots of tests. All right. That should be it. Thank you for your time.
Thank you.
And we will see you tomorrow.
What about this?